All right, so this is the Unit 3 test review, so let's check out what we got here. So first question just asks, which relation is not a function? So just pick which one is not a function. So what we're going to do is look at our inputs. We're going to look at all the x coordinates, and we're going to make sure that they're all unique. So I've got 5, 2, 3, and then 5. So now all of a sudden I've got two 5s. Since these numbers are different, we cannot have that one. That one's not a function. So the first one is not a function because there are two 5s as the input. Or you could just say there are two inputs that are the same or two x values that are the same. Now again, notice I didn't stop at these ones because those are outputs. We don't really care about the outputs when we're looking at function. We have to make sure that the outputs are all unique. Or if they're not, they at least go to the same output. So inputs need to be unique. So we got 9, 8, 7, 5, and then again we got another second 5. So again, that one's out because the 4 and the 8 are different. So this is actually the same thing as the second one. So Ka is also the same. So two 5s are as the input. For the next one then, so let's check out Sa. We got 7, 5, 6, and now all of a sudden we see we've got another 7. 2 and 3 are different. So this is no good. You can't have two of the same. So that's the reason that one's not it. So here we've got two 7s as inputs. Again, we want the inputs, we want the x values to be unique. And then for the last one, well, I guess since there's only one left, it's got to be the last one. But let's just double check. We got 9, 8, 6, 4, 2. Those are all different, so I'm going to pick that one. So again, with that one, not too bad. The key is to just look and make sure that the first numbers are all different. So usually that's the key on that question. All right, for number 2, we have our relation map. So first thing it says, part A is to identify the domain. Remember, the domain is going to be the same as the x values. So I got 5, 10, 15, and 20. So that'll be easy. 5, 10, 15, and 20. All done. Identify the range. That's all the y values. We can see we've got 4 from there. -3, -1, 1, and 3. So that's easy. Pretty nice. And then C, what's the best description of the relation? So if I look, first thing I'm going to do is check if it's a function. So we got 1, 1, 1, 1. So it's a function because all inputs go to only one output. So let's see which ones are functions. This one says function, so that's okay. This one says function, this is okay. This one says not a function, well, that's not true. So if there were two arrows coming from the 5, then we would pick this up. We'd say that it's not a function, but since it's just one arrow from each, again, just like the first question, all the inputs are different. There's only one, so it's going to be a function. So now we have to decide if it's 1-to-1 or not 1-to-1. So if it's 1-to-1, that means that we're going to have the same relation over here. So we've got 1, 1, 1, 1. So it is going to be 1-to-1. So it's 1-to-1 because it's a function, so it has to meet the first criteria. And it does, so it meets the first criteria. And all outputs come from one input. Again, that's another way of saying that just all of these arrows, there's only one arrow to each of them. Now, if there was two arrows to like the -3, let's say the 15 pointed to the -3 and the 20 pointed to the -3, then it would be not 1-to-1 because there would be two going to the -3. But that's it. That's all we got for this question too. So again, not a lot of calculations, but we got some thinking questions. All right, for number 3, given g of x is k of x times f of x, what value of k transforms f into g? So the key on this one, since we're doing multiplication, again, it might not be multiplication on the test, so we studied multiplication and addition, so it could be either one of them. But for multiplication, we can see that we're going to start, so the y-intercept starts at -1. That's for f of x. And we can see where it ends. So for g of x, it ends at -3. So we'll say y-intercept goes to -3. So we have to think, how do we multiply -1? So -1 times something is equal to -3. So we can solve for that if we can't figure it out logically. We can divide both sides by -1, and we're going to get x equals 3. I guess it should be a k since we're using k in the question. Let's switch these to k, since that's what we're multiplying by. K doesn't go there. All right, so this is k equals 3. So that's what we're multiplying by. We can see we're stretching it out. It's getting 3 times as large. So we're stretching it out by a factor of 3. What I had here, I'm going to multiply by 3 to get this stop. And we can double check. Here, this is 1, 1, 2, 3. Oops, 1, 1, 2, 3. We can see we're multiplying that point by 3 also. So this is if we're multiplying. Now, if we were adding, because again, I could also ask adding. Those are the two that I'm allowed to ask. If I were adding, well, there's more I could ask. But if I was adding, I could ask inside or outside. But if I wanted to do f of x plus k, then instead of a multiplication, we would say we start at -1. We would go to -3. And instead of doing a multiplication, we would just ask, well, -1 plus k equals -3. We're going to say this is an if. And this is what we can add 1 to both sides. And we would say that k equals -2. And that makes sense because I could also just drop it down 2. Now that doesn't make any sense in this one because you can see the slopes are different. But if the slopes were the same, I would just drop it down 2. That would be another thing that I could ask. So again, there's a couple things that I could ask. Adding is the other one that's normal. We have the multiplying. I could also add on the inside and move it left or right since we studied that in class 2. But these are the two normal ones that, if you know these ones, you should be pretty good. So that's our transforms. So again, we want to look very carefully as to what we're actually doing. All right, number 4, kind of a big question only because there's a lot of parts. Because again, the goal of this whole topic wasn't to do like one big question. It's to do a question with a lot of little parts and think about a lot of the answers. So it says, Angel works on the weekends. Each day she earns a set amount plus an hourly wage. Write a linear function p of x Angel can use to determine her pay. So we got two choices. If we want, we can just jump right in and we can use our slope equation. We could do y2 minus y1 over x2 minus x1. We'll pick out some 2 nice points. We got x1, x2, y1, y2. So our slope is going to be 17 minus 13 over 1.5 minus 1, 4 over 0.5. And if we calculate that out, we would get 8. So we know that the slope is 8. So if we're doing y equals mx plus b, like we should for a linear function, oops, we got function here, so we're going to p of x. Sorry about that. P of x equals mx plus b. So p of x equals 8x plus b. So that's pretty good. Again, we got our slope from all the way up here. This is going to come all the way across into m. So we have our basic equation. And now, just like we did in Unit 2, if we want, we can pick out one point. I'm going to pick this one just because it's the first one. 1's a pretty easy number to work with usually. We'll get 13 equals 8 times 1 plus b. So in that case, I have 13 equals 8 plus b. Subtract 8 from both sides, 5 equals b. So our final equation is going to be p of x equals 8, because that was the slope. We already found that one. X, and then we found the b was 5. So we're going to say plus 5. So there we go. Now, again, that's if we wanted to go and do it like we did in Unit 2. Believe it or not, that's kind of the long way. So in this topic, we kind of found some shortcuts here. And the shortcut we can find is if I'm going to go from 1 to 2, I can see I'm going up 8. So I already know that this has to be 8. I didn't have to do the whole equation if I didn't want to. And we know that the y-intercept is what happens when we're at 0. So if I really want to, again, I can think about this. I can say, well, wait a second. If I were to go back 1, I would be at 0. So instead of going plus 8, I would have to go minus 8. Well, 13 minus 8 is 5. So I know I'm just going to have 8x plus 5. So again, I can think about it and get the answer really quickly. Or if I'm not sure, I can always go back to some of the tricks that we did in Unit 2. Obviously, if you want to throw that in Desmos to your graphing calculator, you can also do that. I'm going to do that a little bit later in the review. But if you want to use the table and get the answer for the calculator, you can do that as well. So there's a lot of different ways to do that. The preferred way would be just to look at it and get the answer. But I know since we're doing a review, sometimes it's a little bit weird if I just write down the answer and say, well, you just see it and there it is. But this is how you can calculate it just like we did in Unit 2. So next up, we have to pick a reasonable domain for the situation. So remember, domain is the inputs, domain's like the x's. So if we look here, the hours are the x's. So we have to think about what would be a reasonable amount of hours. Well, all of these look pretty decent. They all got x's. They all are definitely numbers of hours. So we have to come all the way back up here and see that she's working on the weekend. So we have to think about how many hours somebody would work on the weekend. So for a weekend, that would be 2 days. So 24 times 2 is 48 hours in the weekend. So we're not going to pick these because there's not enough hours in the weekend. And she probably needs to sleep. So probably working for 36 hours in 2 days may be a bit much. So we're not going to pick that one. Now, could she? Maybe, but I think it's a little bit more reasonable for her to just work for 8 hours over the weekend. So maybe she's got 2 4-hour shifts. Maybe she works for one day. Maybe she works on Saturday and is off on Sunday. So has one full-time, like 8 hours. That makes a little bit more sense than the 36. 36 would be a lot of hours. Again, I'm not saying it's not possible, but I would be the most reasonable choice in this case. So 8 hours would be the most reasonable option. And then lastly, we got part C. So Angel's going to work from 12 o'clock to 7:30. How much would she earn? So what we want to do is find out how many hours this is. So 7:30, so from 12 o'clock to 7:30, that is, well, conveniently, it's just 7.5 hours. Again, if you can't see that, it's actually easiest to turn this into military time. So then you would do 1930 minus 1200, and we would get 730, which is 7.5 hours. So that's what we could do. So we know we've got 7.5 hours, and what we're going to do is plug that into our P of X equation. So P of X equals 8x plus 5, and we're going to plug the 7.5 in for X. So we get P of, there's another X there, 7.5 equals 8 times 7.5 plus 5. And then we could throw that in a calculator if we want. 7.5 times 2 is 15. So we got 4 copies of that. So that's 60. 60 plus 5 would be 65. And so that's how much money she would earn. She'd earn $65. So there we go. Okay, cool. If we want to actually interpret this, she gets $5 for showing up effectively, and then $8 an hour. So maybe this isn't the best job that she's got, but you never know. Maybe she really likes it. That's what we got for this question. So, all right. So we'll move on. On to number 5. So it says, given f of x equals 4x minus 6, and m of x is 2 times quantity 4x, what's the equation of slope-intercept form of m? When we did the quiz, this one turned out to be a little bit tricky. But we can see we got the 2 out front. So really all we're going to do is multiply everything by 2. We'll distribute the 2. So we get 8x minus 12, and we're done. That's it. So again, we just have to follow what's happening. So here we've got the 2 on the outside. That means we multiply everything by 2. If we had the 2 on the inside, we would only multiply this one by 2. If we were adding 2, we would just do a plus 2 on the end. Remember, those are all normal things that we've done in class. So you just have to be careful to see where these vet numbers are. But that's it with number 5. For 6, one of the following is an arithmetic sequence. Circle it. For the others, explain why they are not. So remember, for an arithmetic sequence, that means we have to add or subtract the same amount every time. So let's see what we got. So 2 to 5 is plus 3. First one's always free, so that makes sense. 5 to 10 is plus 5. Immediately that one's out. So here we added 2 different numbers. So we add by 2 different numbers. So we can't pick that one. All right, let's check out B. So we got 5. That looks good. We got plus 5. This looks really good. We got plus 5. This is looking really good. We got plus 5 again. This is looking really good. But then we've got minus 5. So this one's out because this person, or for this sequence, we're adding, then subtracting. So there's no way that one can be right, because remember, we have to add or subtract just by the same amount every time. Even though it's 5, you can't mix the adding with the subtracting. All right, so this one then, we're going to go, looks like we're going down 2. Again, if we weren't sure, we could always do -4 minus -2 is -2. Here, it looks like we're going down 4. Again, if we want to check, -8. Oops, that's the wrong place. Minus -4. That's like -8 plus 4 is -4. So we can get rid of that one too. And the reason for this one is we're not having the same amount, so we're subtracting by different numbers. Similar to how the first one was, similar to A. So that, again, just like before, like D has to be the right answer, but we can double check it. Plus 6, plus 6, plus 6, plus 6, and plus 6. Again, if you're unsure as to what is going up or down by, you just subtract them. So 10 minus 4 is 6. 16 minus 10 is 6. 22 minus 16 is 6. 28 minus 22 is 6. 34 minus 28 is 6. So again, you can do them all out. If you'd want to put them in the calculator to double check, that's what you would put in the calculator. If you can just see it, obviously that's the overall goal. That's the mastery goal for this section, is to be able to kind of look at it and just kind of do it in your head. But the calculator can help out if you just want to double check it, or if you're just not sure, because sometimes you might make a mistake because you're going a little bit fast. Not a bad idea to double check it. All right, for number 7, we have to get the recursive formula for the arithmetic sequence. So the recursive formula is the one that says A1 is going to equal some number, and then A sub n is equal to A sub n plus 1 plus some other number. So that's it. All we're doing is trying to fill these in. So A sub 1 is always the first number, 12. A sub n plus 1 plus the red number. So our second number is always going to be, we take 2 in a row and we just subtract them. So kind of like we were looking at in the last one. So 38.25 minus 33, I'm going to do 0.00 just to make everything line up. I don't have to borrow or anything, so 5.25. That's how much we're going up by every time, and that makes sense. 12 plus 5.25 is 17.25. And we're done. That's it. So we're not doing any sort of big calculations. We're just kind of writing out the recursive formula. So we have to remember that that one is the recursive one. So this is usually the challenge for these ones, is remembering which one is the recursive and which one is the explicit formula. Now here, this is a really good hint, because right here, that's the recursive formula. That's exactly what we had. Oh, I made a mistake. Well, that's okay. Yeah, we need the last one, not the one after it. So we definitely need that to be n minus 1. But that's okay. And that's why we double check. Oops. All right. Yeah, sometimes in the discrete class, we'll make this one n plus 1 and that one n. But that's all right. N minus 1 right here. So look, you got the formula right there. So unless you really screw it up, you can use the test to your advantage, and that's what you should be doing. So now we have to get the explicit formula. Now, wait a second. Over here, we didn't have the explicit formula, so maybe now we have to memorize what the explicit formula is. Well, the explicit formula is a lot like y equals mx plus b, but we just kind of flip everything around. So it's going to be a sub n equals, and then instead of b, we've got a sub 1 plus n minus 1 times d. And remember, m is like d, b is like a sub 1. It's not exactly the y-intercept. That's why we got that minus 1 there. And just like before, we're just filling them in. So if we look, a sub n equals a sub 1. Well, it just tells us what a sub 1 is, so that's pretty easy. Plus n minus 1. All right, then we got to find d. We got to find the common difference. All right, we're going up by 8 every time, so times positive 8. And that's it. We're already done. That's where we find d. D is how much we go up by every time. So that one's pretty much done too. So that's another pretty quick one. Again, if you know the formula, super easy. If you don't know the formula, it's going to be kind of hard. So you got to remember the formulas. Luckily, there's not too many formulas for this section. This is really the two major ones. All right, next up, we got to do them again. So we're doing another recursive and another explicit. So again, for the recursive, we've got a sub 1 equals a sub n equals a sub n minus 1 plus, again, we're just filling in our two blanks here. And again, if we wanted to go back to double check, we can look up the recursive formula right there. All right, so a sub 1, what we start at, one submarine sandwich is $8. So we're contextualizing what the first one is. And then how much we're going up by every time, each additional sub costs $4.50 more. So again, maybe the sub shop's having a special. That's fine. That works. Maybe they're trying to entice you to spend a lot of money on delivery. Maybe there's a big delivery fee, but whatever, it's not in here. So there we go. So now we need the explicit formula for the situation. So the explicit formula is a sub n equals a sub 1 plus n minus 1 times d. And again, we just have to think about what all of these things mean in context. A sub 1 is the cost for one sub. It's $8 right there. N minus 1 doesn't change. And then D is how much per sub extra. It's times $4.50. And there we go. That's it. We're all set. So we got our two answers. I guess I got to circle this one too. But that's it. So again, if we got those down, those are going to be some easy points, which is good because these ones are worth a decent amount of points. Because again, there's a lot of parts to know. You have to know both the formulas and you got to fill things in the right spots. So there's a good chance that you can get a lot of points on these questions. Oops. Went too fast. All right, number 10, which R value suggests a strong positive correlation? Well, this is the easiest to make a 50-50 out of. Let's get rid of these negative choices. And now we just have to decide which one is strong. So the idea is strong is close to either 1 or negative 1. Weak is close to 0. So if I'm looking, 0.99 is pretty close to 1. So I'm going to pick that one. This one is pretty close to 0. I mean, 0.18 is kind of closer to 0 than 1. This is probably going to be a weak one. So I'm not going to pick that one because that's the weak choice. So again, weak, we think about as small numbers in terms of absolute value. Strong is going to be these big numbers in terms of absolute value. So this would be a negative weak, and this one would be a negative strong. Again, very quick, not really anything to calculate. Number 11, this table shows test scores for 6 students. Do the data show a positive or negative correlation? So remember, we're just looking at the points for correlation. So as the x's go up, what do the y's do? Okay, well here they're already in order. So we're going to say that these are the x's and these are the y's. So as history goes up, it looks like the math in general, so this time they're flat, but up, 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 up is 0. I think the positives win, so I'm going to go with the positive because there's more positives than not. Can the data be used to show causation? The answer is basically always no. So again, this would say if we had to answer yes, that would mean that everyone who is good at history is automatically good at math. No would mean that some people who are good at history, some are good at math, some are bad at math. And that's fair. Because not everybody who likes history likes math. Not everybody who's good at history is good at math. Some people are good at history and bad at math. Some people are good at history and good at math. So this would be a no for causation. So we don't want to pick that. Causation means it has to happen every single time. So most things that are in the real world are not causation. Correlation does not cause causation. All right, so I think we're at the end. This is the last one, yeah? Yep. So there's a lot of parts to this one. You can see it's a really big question, but each of the parts is really short. So we just have to kind of calmly do every single part. So we're going to start with A. A says make a scatter plot of the hours Jack spends at the counter as a function of the number of cakes he bakes. So we're just doing a scatter plot. We're just plotting all the points. So I'm going to do that in black. That seems like it's nice. All of these are right here. So we got 2 cakes, 4 hours, 3 cakes, 4 hours, 5 cakes, 1.5 hours. So I got to be careful because these ones are going up by 1. These are going up by 0.5, so I have to be a little careful. 6 cakes, 2.5 hours, and then 7 cakes, 1.5 hours. All right, well, that's part A. All right, that seems pretty easy. That should be an easy point. Part B, draw a trend line. So we did pretty good when we did this in class. So I'll draw my trend line. I just have to make sure it kind of goes through some of the dots. So I don't know, maybe something that looks like that. That looks decent. Pretty much you'll get points as long as you don't play connect the dots. So if you play connect the dots, if you do a jagged line, then you don't get any points for that. But if your line is reasonable, then you'll get the points for that one. So that's it for part B. So that looks like a trend line. Remember, do not connect the dots. That's basically the easiest way to lose points, is if you connect the dots. You want a trend line, you want one straight line. It could be up, could be down, but this case where it looks like we're going down, and that's the answer to part C. So we have a negative correlation. So we can see we're headed downwards. So it says as he makes more cakes, he spends less time at the counter. And then logically, that kind of makes sense. All right, which could be an equation for a trend line for the data. So now this is where things get a little bit tough. So we have our trend line. If we look at our y-intercept, it looks like we're kind of around 5. So I would guess it's going to be one of these ones that's starting around 5. But it's really tough to tell what the better slope is, whether it's negative 0.5 or negative 0.8. So this is where you could kind of make a guess at it. I mean, it kind of looks like we're going down 1 over 1, which would be about 0.5, but it also doesn't look exactly like that. And depending on how I draw my trend line, I could have made my line a little bit steeper. So I'm not very confident to answer part D without actually figuring it out, just because a lot of those choices are just too similar. So what I'm going to do is I'm going to use the calculator to help me out. So I'm going to go over here. I'm going to hit the stat button. I'll press enter, and I'm going to put in all of my data. I forgot my data. 2, 3, 5, 6, 7. All right. 2, 3, 5, 6, 7. All right, then I'm going to come over to L2, and I don't know my data again. 4, 4, 1.5, 2.5, 1.5. All right, so I'm going to got all my data in. I'm going to hit the stat button again. I'm going to press over. I'm going to pick the linear regression. I'm going to pick number 4. Press enter a few times. And okay, so this is what the calculator gives me. Now again, this is a little bit interesting because that's not any of the choices. So I don't want to do that. Let's try that again. Okay. So in this case, we can see we've got negative 0.5. There we go. 2.9 is our slope. We're going to bring that back over here. And we've got 5 as our y-intercept. So again, 5 is probably the best choice for the y-intercept. So based on this, I'm going to be pretty happy with choosing the 5s and not the 3.5s. Oops, and not the 8. Now again, with our a value, this is kind of like the slope. Negative 5.3 is a little bit closer to 0.5 versus negative 0.8. So I'm going to pick this one. Now again, the way that you draw your line, it could actually be the other one. So you do have to kind of double check. Kind of a tricky one to get right. So that's what we got. If you want to do it in Desmos, let's bring up the Desmos real quick. And we'll do it in Desmos as well. Remember to bring up a table. We get the little plus sign up here. Little cross. We do the table. Put in the data 1, 2, 4, 2, 3, 5, 6, 7. 2, 3, 5, 6, 7. And over here, I think it was 4, 4, 1.5, 2.5, 1.5. All right, so we got our dots. We can make it look nice if we want. And we got to type in our code, y1 tilde mx1 plus b. Yeah, so we can see we got that negative correlation. That looks pretty good. And again, it gives us a very similar choice. I'm going to grab all this just to save it onto the screen. I want to save it to the current page. There we go. And again, you can see we get basically the same thing. So 0.529069, 0.52907, 5.13372, 5.13372. So we get the same answer with both of them. Again, that negative 0.5 tells us that that's what we want to pick. All right, so that's kind of that part. So again, that one's kind of tricky, but the math that you used to solve it, we did in that previous unit. So it's almost like a review question. All right, part E says, what does the y-intercept of the trend line represent? So if we come up here to the y-intercept for the trend line, so the y-intercept would be up here, because it's where we hit the y-axis. So that would be when there are 0 cakes. So the y-intercept would be 0 cakes. So let's see which one makes sense for 0 cakes. Average time it takes to bake 1 cake. No. Average number of cakes per hour Jack can bake. No. Total time spent baking cakes. No. Number of hours Jack is at the counter before any cakes are baked. Yes. So that would be the best choice for that. If he bakes no cakes, that's about how long he's at the counter. Now, again, if we think about this logically, yeah, if he's not spending time making cakes, he's probably at the counter selling the cakes. That makes a lot of sense. So that's what we want to do for our y-intercept. All right. Total time spent baking cakes, that would just be the x's, I believe. Yeah. No, it'd be the... So you have to find out how many hours he works and subtract the counter time. So that one seems very complicated. Average number of cakes per hour would be the slope of the trend line. And then average time it takes to bake 1 cake, we don't actually know because it doesn't tell us how long he's actually baking cakes. So that would also not be true. So all these other ones are a little bit weird. Part F, estimate the time Jack spends at the counter when he bakes 4 cakes. So we come over here and we just kind of say, all right, well, if I'm at 4, we're right there. So it looks like between 2.5 and 3, I don't know, maybe like 4, 2.9-ish. So I'll say 2.9. If we want, we could use the equation to solve it out precisely. So if I really wanted to, I could choose my answer over here and do negative 0.5 times 4 plus 5, negative 2 plus 5, not plus 4. Plus 5 is 3. So I could pick 3. I could pick 2.9. But again, since it's an estimate, if it's anywhere around 3, then that would be reasonable. So either of those choices would be reasonable because it is an estimate. And lastly, just a quick vocab, is it an interpolation or an extrapolation? So remember, the idea here is an interpolation is within the data. and extrapolation would be outside the data. So if I go up to my data table, if I was over here, this would be extrapolation. If I'm over here, this would be extrapolation. So more than 7 or less than 2. But since I'm inside here, this would be an interpolation. So 4 is inside the data, so 4 is an interpolation. And that's it. So there we go. So that's all of them. So again, not really too much work on these ones, but a lot of thinking things. So there's a lot of concepts to know. Really, the only main equations, I believe, were just our formulas, right? So our recursive formula and our explicit formula. And so number 9 there, it has both of them right there. So that's what we got for the Unit 3 test. So we're all set. All right.